Bless you. All right. Good morning, everyone. Hope everybody's doing great. Hope you had a great weekend. Today we'll begin our conversation with 11.1. View of measurements. So we're starting off with the US system. It's called the US system because the one who mainly uses it is the US. We'll talk about the one that the world uses in a few minutes, but we're looking at the US system first. Now, these are not all the conversion factors in the US system. And of course, I'm not going to put every single one of them, but just understand that these don't change. So there's always going to be 12 inches in 1 foot, no matter what book you pull up, no matter if you ask Alexa, Siri, or whoever you ask, these are fixed. They will always be the same. So the first one is 12 inches equal to 1 foot. Then we have 3 feet equal to 1 yard. 36 inches equal to 1 yard. 5,280 feet equal to 1 mile. All right, so let's see how we're going to use this or use them. So if I have 18 inches and I want to convert that to feet. So the first thing we'll do is look for the measurement or the conversion factor that involves inches and feet. So that's that first one, 12 inches is equal to 1 foot. And I'm going to erase some of this stuff down here so you can see how we're going to start off. All right. So the way that we use these conversion factors, we start off by taking what we have initially and placing it over 1 to create a fraction. So I got that 18 inches, and I'll place it 18 inches over 1. Please get out my room. All right. So when we go back to our conversion factor, we have 2 choices in how to use it. Either I can use it as 12 inches over 1 foot or 1 foot over 12 inches. Same 2 pieces, just one is on top of the other, or vice versa. So now what's going to dictate whether I use either one is that I have this inches right here. Whatever I start off with has to be down bottom. All right. So let me go ahead and put what I had back initially. All right. So that means I'm going to do 1 foot over 12 inches. And what that allows is for my inches to cancel out. I have inches in the top, and now I have inches in bottom. And that allows the measurement for inches to cancel out, leaving me with just feet, which is what I wanted to convert to. And then that's 18 over 12 feet, which is 1.5. Or if you want to leave it in fractional form, that would be 3 over 2. Either or is fine. And so this thought process is coming from, how we cancel out fractions. If I have 4 over 6, there's a 2 that's in common with top and bottom. They can cancel out, leaving me with 2/3. So it's the same thing that's happening with these measurements. I have inches initially, so I need inches down bottom so that they can cancel out and leave me with the feet. And then from there, you go ahead and multiply across and simplify. All right, questions on that before we do another one? What should we do? Next one, we have 14 feet. We want to convert that to yards. All right, so I'm going to use 3 feet equal to 1 yard as my conversion factor. I'm starting off with feet, so that means I need feet down in my denominator so that they can cancel force. That leaves me in yards. So now multiply across, that's 14/3. And you can leave this 14/3, or that's 4.6 repeated. All right, scrolling up. 3.5 tons. We want to convert that to pounds. So since we have a mixed number here, what I did was convert that to an improper fraction. And don't forget how that works. You take your whole number, multiply it to the denominator, add it to the numerator. So that's 3 times 2 plus 1. So that's how I got some, bless you. That's how I got the 7/2. And you keep the same denominator throughout. So that's 7/2 tons. Haven't converted anything yet. That's just changing your mixed number to an improper fraction. So now you take that 7/2 tons, and we see that there are 2,000 pounds equal to 1 ton. I need tons in my denominator because I have tons as far as my measurement that I'm starting off with. So that's 7/2 tons, 2,000 pounds over 1 ton. The tons cancel. Multiply across, that's 14,000/2 pounds, which would ultimately give us 7,000 pounds. Mhm. So I know we'll do at least one more converting that way, but any conversion factor, this is how you would convert. You set up your fraction and then find a conversion factor that lines up with your fraction and what you're trying to convert it to, aligns up with your measurement and what you're trying to convert it to. Make sure that the one you start off with is the one that bottom of your conversion factor fraction. And then from there, multiply and simplify. All right. So let's look at the metric system. Right down with the red. Okay. So let's look at the metric system. Here are some of our basic metric system prefixes. Now, the metric system is what the world uses. Like I said, the US is trying to hold on to the other stuff. And we are doing it, not trying, but we are. But the metric system is what is universally used. And so we have these prefixes, kilo, hecto, deca. Then we have our base, which is going to be grams, meters, and liters. Gram, meters, or liters, depending on what you're measuring. Then we have deci, centi, and milli. And then you see our abbreviations for each: K, H, DA, GML, DCM, and then the value for each. So these are just base prefixes. Yes, sir. Oh yeah, for sure, for sure. Yeah, you don't know that to ask me. You good. So these are just our base prefixes, but they do get very, very large and very, very small. Some of you've already been exposed to, like mega, like megabytes, gigabytes. So mega, giga are all very, very large prefixes, and very, very small ones are like nano. So we exposed to that when we talk about COVID with nanotechnology, and pico. I'm not sure we have an example of pico in our everyday lives, but pico is another one that's very, very small. They go well beyond the milli. But yep, we talk about how we're gonna use these in a second. Just give me a chance to write them down. Hmm. All right, scrolling up. All right. So with the basis, oh, let me erase that 9293. Those are old notes. It's all one section. All right. So our basis, meters, liters, and grams. So we use the M for meters, capital L for liters, then lowercase. So the M and the G are lowercase. It was capital. But that G is for grams, and then liters measure volume, grams measure your weight. And either one of those prefixes, it doesn't matter. It just depends on how large or how small your measurements are. But either one of those prefixes can go in front of either one of those bases, just depending on, once again, what you're measuring. So you could have kilograms, kilometers, kiloliters, or centigrams, centimeters, or centimeters. All right, scrolling up. So now when it comes to the metric system, it's not really about calculation. I mean, it can be depending on how you want to do it, but if you can remember the order, you don't have to lean on calculating. You can remember King Henry died by drinking chocolate milk. So the K is kilo, H is hectare, D is deca, B is one of your bases, depending on what your base is, grams, meters, liters, D deci, C centi, and then M for milli. But King Henry died by drinking chocolate milk. If you can remember that, then you'll see when we go to do our conversions, it's really about moving your decimal to the right or left. All right. So let's go ahead and try this out. So it says convert 0.38 meters to millimeters. So first thing we want to do is, like I said, remember the order. King Henry died, buys our meters, drinking chocolate milk. So you see how we got to set up kilometers, hectometers, decameters, meters, decimeters, centimeters, and millimeters. All right. Then from there, we're starting in meters and we want to go to millimeters. So we're starting in meters and we want to go 1, 2, 3 to the right. And so that's what we do with our decimal. You see, I have it down here. I took that point that's in front of the 3 and moved it 3 to the right. And you use as many zeros as placeholders as needed or necessary. And that gives us 380 millimeters. All right, let's do it again. 12.9 centimeters, and I want to go to hectometers. So starting off with centimeters, and I'm going 1, 2, 3, 4 to the left with my decimal. And so move that decimal 4 to the left. We're going to use 2 zeros as placeholders this time. And it's 0.00129 hectometers. Let's look at grams. Once again, it's the same process, whether it's meters, grams, or liters. I just want to go ahead and give you an example of grams. So 4.23 decagrams to centigrams. Order still the same. It's just that we're using G's instead of M's. So you see kilograms, hectograms, decagrams, grams, decigrams, centigrams, milligrams. And always just be careful. Sometimes we forget to put the base in there, whether it be grams or meters or liters. Make sure you don't forget that piece or that part of your order. And then from there, in decagrams, we're going to go 1, 2, 3 to the right. Move your decimal 3 to the right. That'll be 4,230 centigrams. Anybody hold on to the top one? All right. So last one like this, just an example of liters. Got 1,579.64 milliliters, and we want to convert that to hectoliters. And going from milliliters to hectoliters would be 5 spaces to the left. And moving the decimal 5 spaces to the left, that's 0.0157964 hectoliters. All right. One more, and then this one's going to take us back to what we were doing initially. So we have US to metric. So it is possible to convert from US to metric, metric to US. But in order to do that, you're going to have to use a conversion factor like we did before. So anything involved in the US means that you're going to have to use a conversion factor and do the fact using that fraction and multiply, cross, simplify type of thing. So 55 miles to kilometers. The miles US, kilometers are metric. So that's 1.61 kilometers equal to 1 mile. All right, so set up your fraction, 55 miles over 1. Multiply that times 1.61 kilometers over 1 mile. Remember, the mile has to go down bottom because it needs to cancel out with the mile up top. So if you multiply across 55 times 1.61 is 88.55. 1 is in your denominator, and that leaves you with just 88.55 kilometers. See, don't worry about temperature. If I remember correctly, I didn't see one dealing with temperature. So, but if you do see one dealing with temperature, let me know and then we can go over it. But I don't want to give you stuff that you don't have to worry about. So let's look at 11.2. We can start it. Or might be able to finish it. We'll see. But just basic concepts of geometry. So we have X, Y, and Z are all on line L. Given XY is 9 meters and YZ is twice XY, find XZ. All right, so when we look at this segment, you see XY is this piece right here. Right over this line. We have a segment of the line, which is XY, and then YZ. XY plus YZ gives us XZ. So that's where I got this equation from. So there's no guarantee they're going to give you that equation, but you should be able to look at this line and see that relationship and see that connection. Once again, XY is this piece, YZ is this piece, and then XY plus YZ gives you the whole segment of XZ. All right, so they give us XY, which is 9, and then the relationship with YZ in reference to XY, which is YZ is 2 or twice XY, is 2 times XY. So we can substitute that relationship in for YZ. Now we can put 9 in for XY. Everybody hold on to the red as I scroll up. That'll be good. All right. So, and then go ahead and do the math. 2 times 9 is 18. 18 plus 9 is 27. 27 meters. All right. Still see writing. Thought I had a second one up there. It's all good. Everybody holding on to blue. All right. Next thing, parallel lines, lines that never cross or touch each other. Perpendicular lines, they're lines that create a 90-degree angle at their intersection. So you can never assume that you have parallel, excuse me, well, either or. You can never assume you have parallel lines or perpendicular lines, most definitely perpendicular lines. I mean, 89 degrees versus 91 degrees may look like 90 degrees to the naked eye. There has to be something that identifies the relationship that these lines have. So when it comes to perpendicular lines, there may be a square right there identifying that that's 90 degrees. That square represents 90 degrees. Or it may just be in the wording, say we have two perpendicular lines, or it may say we have two parallel lines. But either way, you can never assume that you have either. Something has to identify those for you. All right, scrolling up some. By holding on to perpendicular lines. All right, angles, just two rays with the same endpoint, and that endpoint is called the vertex. Yeah. Okay. That good enough? Mm-hmm. All right, now scroll up. Everybody good? Everybody good? All right, so let's look at these types of angles. So the first one is acute. That's when your angle is between 0 and 10. Right angle, 90 degrees. Obtuse is when your angle is measured between 90 degrees and 180. Straight angle, or you can think about just a straight line, is 180 degrees. All right. Then one full rotation or revolution is going to be 360 degrees. All right. Rolling up. All right. So complementary angles. Just two angles that add up to give you 90 degrees. So 50 and 40 are complementary. 1 and 89 are complementary. All right. Supplementary angles. Just two angles that add up to give you 180. That's 150 and 30, 2 and 178. All right, scroll up. So we'll do a few examples that apply to these terms that we have. So given that the measure of ABC is 84 degrees, find the measure of X. Anybody holding on to supplementary? All right. So I'll get you a chance to write first of all. All right. So for this type of problem, you don't necessarily have to set up an equation, but I just did it for board purposes to make sure we understand what we're doing here. But you see that ABC is equal to 84 degrees. They give us this piece of ABC as 47 degrees, and we want to figure out what is this missing piece. So, I mean, I just set it up as an equation. X plus 47 is equal to ABC. So we subtract 47 from both sides because you know ABC is equal to 84. So 84 minus 47 is 37. So, you know, you could have just said, well, both of them equal to 84, subtract 47 from 84, and that's fine as well. Like I said, I did that more so for board purposes, making sure we're okay. All right. All right, so next one, ABD and DBC are supplementary angles. Remember, supplementary means that they add up to give you 180 degrees. If ABD is 66 degrees greater than DBC, find the measure of each angle. So the answer's over here to the right. So we wouldn't know those was over there to the right of those arrows. So basically set up this way, whether they give you the diagram of not, or this figure or not, we know that we have this angle that's labeled DBC. We have an angle that's labeled ABD, and we know they add up to give us 180 degrees. So now the relationship they give us in reference to the both of them is that ABD is 66 degrees greater than DBC. So, but they don't tell us what DBC is. So what you would do is call DBCX and then call ABD X plus 66. All right. Make sure we're okay with the initial setup. Because of the relationship and the lack of information, we would call DBCX because we don't know what it is, but we do know what ABD is in reference to DBC is 66 degrees more. So we do X plus 66. So now that we have a algebraic representation of each piece, we can now use the fact that they are supplementary angles and set up an equation. So we know both of them added together will give us 180 degrees. So I got x, then x plus 66 equal to 180. Those parentheses are just there just to signify where each piece came from. We had x, then x plus 66. We don't need to hold on to the parentheses. We can go ahead and combine it like terms. X and x is 2x. Now we subtract 66 from both sides. That'll be 2x equal to 114. Divide both sides by 2. X is equal to 57. So now that you have x, you can go ahead and solve for both pieces. Let's see if I can get that in here. All right. So we know x is equal to 57. So that means that DBC, since that is x, DBC is equal to 57 degrees. And then ABD is x plus 66. So you can do 57 plus 66, which is 123. And that'll give us our two angles. And of course, you can always check it because adding them together is supposed to give us 180. So 57 plus the 123 will give us 180. All right. Questions on that one before we go to the next one? So we're good on that last example. All right. Erase that. All right, next term or next relationship, we have vertical angles. They're formed by intersecting lines. The non-adjacent angles are vertical angles and are equal. So when we look at this x that's created by these intersecting lines, 1 and 3 are vertical angles, 2 and 4 are vertical angles. So whatever your opposite angles are, those are the ones that are considered vertical and they are considered equal to each other. And then with that last statement down there in the green, don't forget that a straight line or straight angle is always going to be 180 degrees. So that means adding 1 and 2 gives us 180 degrees, or well, it's not going to erase one, or 1 and 4 creates that straight line. So they add up to give you 180. 3 and 4, same thing. They add up to give you 180. 2 and 3 add up to give you 180. So keep that in mind, because all of these principles that I'm giving you are going to be things that you can use, or tools that you can use, concepts that you can use to help you come up with the missing angles that they're going to ask you for. Oh, no, so the black statements up top. I'll leave that up there and you just talk to it. All right, so we're going to find the measures of A, C, and D. Now keep in mind, when you have this type of diagram, you wouldn't have these red markings that I put up there. You just have your X and they assume you know that A and C are equal, B and D are equal, because you have lines that are intersecting. They will create the vertical angles. I'll put them back though. So the one that's given is B. B is 115. So in all of these, they have to give you at least one piece for you be able to solve and move forward. So if B is 115, B as in boy, that means D as in dog is 115 as well, because they're vertical angles are opposite of each other. And so that's why over here I try to do is give you a little notes as to why we came up with those numbers. So you know what B is because it was given, you know what D is now because it's vertical angle with B. And it doesn't matter which one you find next, whether it be A or C. I decided to find A, and we can find that because A and B create this straight angle. That means that A and B, when you add them together, gives you 180. So if we subtract B from 180, then we will get A. And so that's what I did right here. 180 minus 115 gives me 65. And that is A. And then to finish it off, we know A and C are vertical angles because they're opposite each other. And so A is equal to C, which is 65.
All right, everybody okay with that one? One more concept, and then that'll be it for this section. Was really a figure with multiple concepts, but we'll get to it. So, let's see how far I can scroll up. Pretty good. Okay. So we have two parallel lines, L1 and L2. Then we have T, which is the transversal. And you see the definition of that. It's just a line that intersects two parallel lines. And so you see that diagram right there, that figure. You see how our two parallel lines and then the T running through those two parallel lines. And you see the angles that are created because of that relationship. And that's going to create three concepts for us. For us. Everybody done with that last example? We're good. Okay, let's look at this first concept here. Whenever you have a relationship with two parallel lines being intersected by one line, it creates alternate interior angles. So hold true to both of those words. They're alternate, in other words, alternate sides of your transversal, and they're interior. So we're talking about these four angles right here. That's inside of your parallel lines. So alternate interior will be D and X, and then C and W. And all this is saying is that those create equal, or that relationship creates equal angles of your alternate interior angles. So D and X are equal and C and W are equal. All right. Next one is alternate exterior angles. So we're talking about these outside angles now, exterior, but then alternate. So that means A and Y, and then B and Z are going to be equal for each other, for us, or equal to each other. So A is equal to Y, B is equal to Z. And then the last one, corresponding angles. They're all equal, so just talking about these four correspond to these four. So AW, BX, CY, and DZ. All right, scrolling up. Let's take that information and find the missing angles. Anybody holding on to corresponding? Corresponding. All right, let me erase some of this stuff. All right, so they give us F, which is 58 degrees, and that's just to find the missing angles. Will just leave that up there. So this symbol just means that they're parallel. You know, so they tell us L1 and L2 are parallel. And that's just to find the missing angles. All right, so let's talk through each one of these. And when you're going about doing them, I'm giving you multiple ways and multiple concepts that will help you to be able to find the missing angles. So you don't have to necessarily use the specific methods that I have, but all the answers still should be the same. So wherever you see 58, wherever you see 122, they should still be the same. Just that you may have used a different concept in order to get there. So first thing that we can get, or first angle we can find, the easiest one is H, because H is a vertical angle to F. So it's going to be the same thing. So H is equal to 58 degrees as well. Now, I decided to go with G next. F and G creates a vertical angle right here. I mean, a vertical angle, a straight angle. And so that means they add up to 180. So that's why I have right here 180 minus 58, or 180 minus F gives me that 122 for G. And then G and E are going to be equal because they're vertical angles to each other. So before we go to the next four, is everybody okay with E, F, G, H? Remember F they gave us, and we had to find E, G, and H. All right. So looking at the top four, now I could have found all four of these the same way. In other words, F, G, E, H corresponds to A, B, D, C. So we could have did that with, but just for board purposes and just for instructional purposes, I decided to use other methods to find the other two. So you see that the first two I found based on corresponding angles. So in the FG corresponds to AB. So F and A are equal, G and B are equal because they're corresponding angles. So that makes A 58 and then B 122. And then from there, I just decided to do vertical angles. B and D are vertical. So they're both 122. And then A and C are vertical. So they both are 58. All right, questions on anything? Make sure we're all right. We have. All right, scrolling up some, okay, that's it for 11.2. And for those who are copying, give me a second, let me look at 11.5. There's triangles, yep. Okay, so yeah, we'll pause right here. That's it for 11.1, 11.2. Next class, we'll get into triangles and go from there. All right. So you guys have a good one. If you haven't noticed, I did open up all your assignments like I told you I would. So if you're missing anything, make sure you get on top of that so you can get caught up. And I'll see you on next class.